Hello everyone, myself Arnav Kumar Modi. Today I am going to present on the topic using artificial intelligence for combating global warming for the course Artificial Intelligence Foundations and Applications. Uh, what is global warming? Global warming is a gradual increase in the Earth's temperature. Uh, Second, the causes of global warming includes like from the agricultural fields, from the other from the greenhouse effects, from burning of fossil fuels, and finally deforestation. Deforestation plants are the main source of oxygen. They take in carbon dioxide and release oxygen, thereby maintaining environmental balance. Forests are being depleted for many domestic and commercial purposes. That has led to environmental imbalances and thereby giving rise to global warming. Uh, from the agricultural perspective, we can see in the agricultural field, the lots of chemical fertilizers are getting used day by day. So for that reasons, the methane and other greenhouse gases are getting emitted from the fields very regularly. So that also is causing like global warming very rapidly. Burning of fossil fuels is another reason of global warming because like that also emits greenhouse gases like carbon dioxide and other CO, NO2 and sulfur dioxide, etc. And so these are the causes of global warming. Like effects of global warming are very large because like you can see like for global warming like there is gradual rise in temperature is occurring. Climate change is inevitable for global warming and also drought, rise in sea level, changes in ecosystems are the key results or key effects of global warming. Uh, Now I'm going to share like how we can use AI to combat global warming. We can do it in four steps. We can say first one is mitigating greenhouse gas emissions from land using machine learning. Second one like reducing greenhouse gas emissions from electricity systems using machine learning. Third one like mitigating greenhouse gas emissions from buildings and cities using machine learning, and fourth one mitigating greenhouse gas emissions from transportation using the by doing the use of machine learning. uh, Firstly, the reducing greenhouse gas emissions from electricity systems using machine learning. uh, Global warming for electricity systems for reducing dependency on fossil fuels. We can develop short-term and long-term forecasting models using machine learning for predicting the availability of wind and sunlight for generating electricity from variable as depends on external factors, low carbon sources like wind turbine and solar panels, etc. And also for predicting where and when to build wind turbines or solar panels. Machine learning can help improve the existing like centralized slow and complex NP-hard optimization problem process of scheduling and dispatch, which is primarily used to determine how much power every controllable generator should produce by speeding up power system optimization problems and improving the quality of optimization solutions using neural networks, genetic algorithms, and fuzzy logic, etc. ML can help prevent the leakage of methane and extremely potent greenhouse gas from natural gas pipelines and compressor stations using the data coming from sensors. Flexibly managing household, commercial, industrial, and electric vehicle demand as well as energy storage can help minimize electricity-based emissions to inform consumers about emission factors. What time estimates these factors in real life for the United States using regression-based techniques. Uh, Next one is like mitigating greenhouse gas emissions from buildings and cities using machine learning. Intelligent control systems in buildings can decrease the carbon footprint both by reducing the energy consumed and by providing means to integrate lower carbon sources into the electricity mix. Especially, ML can reduce energy usage by allowing devices and systems, especially inefficient heating and cooling systems like refrigerators, to adapt to usage patterns. Further, buildings can respond to signals from the electricity grid, providing flexibility to the grid operator and lowering costs to the consumer. An essential step towards energy efficiency is making sense of the increasing amounts of data produced by meters and home energy monitors. This can take the form of energy demand forecasts for specific buildings, which are useful for power companies and in evaluating building design and operation strategies. Traditionally, energy demand forecasts are based on models of the physical structure of a building that are essentially massive thermodynamic computation. ML has the potential to speed up these computations greatly, either by ignoring physical knowledge of the building entirely, by incorporating it into the computation, or by learning to approximate the physical model to reduce the need for expensive simulation. Surrogate models. Specifics about building infrastructure can often be predicted using ML techniques. Remote sensing is key to inferring infrastructure data, as satellite data present a source of information that is globally available and largely consistent worldwide. Using remote sensing data, we can cluster buildings into types to assess the potential of district heat letdown. Now, my friend and colleague Sahil Nawaz is going to present the next two slides, such that mitigating greenhouse gas emissions from transportation using machine learning, i.e. the ninth slide, and the second one or the 10th slide is mitigating greenhouse gas emissions from land use using machine learning.
Globally, the transportation sector accounts for about a quarter of energy related CO2 emissions. In contrast to the electricity sector, however, transportation has not made any significant progress to lower its CO2 emission. This is because of the high energy density of the fuels required for many type of vehicles, which constrain low carbon alternatives. And different mode carry vastly different carbon emission intensities. At present, more than two-thirds of transportation emissions are from road travel, but yeah, air travel has the highest emission intensities and is responsible for an increasingly large share. And there are some strategies to reduce GHG emissions from transportation. First is reducing transport activity. I would like to elaborate this. With the help of ML, the number of vehicle miles traveled can be reduced by making long trips less necessary, increasing loading and optimizing vehicle routing. High leverage modeling demand and planning new infrastructure can significantly shape how long trips are and which transport modes are chosen by passengers and shippers. ML can provide information about mobility patterns, which is directly necessary for agent based travel demand modes, one of the main transport planning tools. Second is improving vehicle efficiency. Most vehicles are not very efficient compared to what is technically possible. Both the designs of the vehicle and the way it is operated can increase the fuel economy. Here we discuss how ML can help design more efficient vehicles and the impacts that autonomous driving may have on GHG emissions. GHG is basically greenhouse emissions. And encouraging drivers to adopt more efficient vehicles is also a priority. And basically there are two things in improving vehicle efficiency. The first is designing for efficiency. There are too many ways to reduce the energy a vehicle uses, such as more efficient engines, improved aerodynamics, hybrid electric engines, and reducing the vehicle's weight or tire resistance. These different strategies require a broad range of engineering techniques, many of which can benefit from ML. And the other is autonomous vehicles. Machine learning is essentially in the development of autonomous vehicles, including in such basic tasks as following the road and detecting obstacles. While autonomous vehicles could reduce energy consumptions, for example, by reducing traffic congestions and inducing efficiency through eco driving. The third is alternative fuels and electrifications. Alternative fuels. Long term, much of the transport sector is highly dependent on liquid fossil fuels. Long distance road transportation and ocean shipping require high fuels with high energy density, and fluids thus are not conductive to electrifications. Electrofuels, solar fuels, biofuels, hydrogen, and perhaps natural gas offer alternatives, but the use of such fuels is constrained by factors such as cost, land use, and for hydrogen and natural gas incompatibility with current infrastructure. Electrofuels and biofuels have the potential to serve as low carbon drop in fuels that retain the properties of fossil fuels. And the fourth is modal shift, that is shifting to low carbon options like rail. Shifting passengers and to low carbon intensities modes is one of the most important means to decarbonize transport. The modal shift in passenger transportation can, for example, involve providing people with public transit, which requires analyzing mode choice and travel demand data. ML can also make low carbon modes more competitive by helping to coordinate intermodal transport. Overall, decarbonizing transport is essential to a low carbon society, and there are numerous applications where ML can make an impact. This is because transportation causes a large share of greenhouse emissions, but reducing them has been slow and complex. Solutions are likely very technical, are highly dependent on existing infrastructures, and require detailed understanding of passengers and companies' behavior. ML can help, however, it can help decarbonize transport by providing data, going knowledge from data, planning, and automation. Moreover, ML is fundamental to shared mobility, autonomous vehicles, electric vehicles, and smart transit, which, with the right incentive, can be used to enable significant reduction in GHG emissions. However, I would like to elaborate more about building and cities. The energy consumption in buildings is responsible for a quarter of global energy related emissions. A combination of easy to implement fixes and the state of the art strategies could reduce emissions for existing buildings by up to 90%. It is possible today for buildings to consume almost no energy. Many of these energy efficiently measures actually result in overall cost savings and simultaneously yield other benefits such as cleaner air for occupants. We have seen many different modes for that ML can help to reduce greenhouse emissions from building and cities. A central challenge in this sector is the availability of the high quality data for training the algorithms, which rarely go beyond many cities or represent the full spectrum of building types. Techniques for obtaining these data, however, can themselves be an important applications for ML, that is via computer vision algorithms to pass satellite imagery. Realizing the potential of data-driven urban infrastructure can advance mitigation goals while improving the well-being of citizens. And this is all building and cities could help in this topic by with the use of ML. So that's all from my side.